Are we good? Okay, we're good again. Okay, let's try this again. Okay. Hello, good morning, bonjour, hello, kamusta, ahoy, right? So I went through all the old finals again to try to find as many of the final questions as possible so we could practice them. So this one isn't a loop question. This one's just a practice question, a warm-up for today. So, question, final 2016, question 1. What is printed when the following is executed? So I define a function, call it add. When I call it, it will print adding and then its input and then return the sum. I'm going to define another function which doubles a number, z, and it will print doubling z and then return the double of z. Now I have this big if statement. So let's first determine which branch of the if executes, right? Either the if or the else. So if we double 10, right? So when you work with these functions, like derivatives, you want to work from like the innermost bracket outward, right? So first I want to do this. So double 10 gets 20, and then we add 20 and 20, which is 40, which is greater than 0. Okay, so this is true. So let's check this. So double of 5. Oh, but we have to remember what we're printing. Okay, so when this happens, we do this first, which prints. Okay, I need to write stuff down then. Okay, just let me open VS Code so we can do this together. I haven't done these, right? So I'm just doing these as you see them. Move. Okay, so what's gonna happen here? So we want to do add 20, double 10 is greater than 0, and what was it? Add minus 25 to the double of 5 is greater than 0. Okay, so let's resolve this one first. What happens? Okay, so first this double 10 gets resolved, and it turns to 20. And I think this prints double, right, what prints? Double of 10, right? And then this add is performed. So I think it says adding 20, 20. And then this gets resolved to true. And then we double 5. So this will print double 5 and return 10. And then we add minus 25 and 10, which gives you what? Minus 15, which is not greater than 0, so that goes to false. So in this code, this if statement, that doesn't toggle. So we print oops, add double 30, okay? We print. So this is tricky, right? So remember, we're printing things. So when we're printing here, what gets printed first? The oops or this, or the stuff that happens in add, right? We're trying to trick you on these exams, right? So I'll tell you, this happens first, and then the print. Actually, I actually don't know. I'm assuming so. Okay, so let's just give it a try. We'll learn today. Unlike other days. What day is it today? Wednesday? Okay, so what did we have? We had some definition of add, which returned x plus y, and it printed adding x and y. So let's just see what happens here. If I say print, oops, add 2 and 3. So my prediction here is that it's going to print adding 2, 3, then oops, 5. That's what I suspect. Okay, so let's call this into Python. Python Wednesday. Oops, that's not actually syntax. Adding 2, 3, oops, 5. Okay, yeah, so I was right. So in this here, this happens first, which means this happens first. We're going to get a double 3 So then we're going to double 3, and then we're going to add 6 and 0, and then we're going to print oops. All right. So I just wanted to show you what a typical question like from your exams are. Right? Like maybe a quarter of the test is trace through these examples. All right, so that was a warm-up. Here is a question now that, oh geez, this may be difficult. Write a function with the following signature. It's a function which takes a 0, 1 bit string and converts it to a base 10 decimal value. Now, remember I was trying to show you this in the first day of class, and a lot of you didn't like it. It's not actually that difficult, so maybe we can try to work through this. I don't know if I should use the board or not. Maybe I'll use the board. I'll try to explain this again, okay? Because it shouldn't be too hard when we do this. Okay, so we have this number, like 123, right? And we know that this is 1 100ths plus 2 10s plus 3 1s. So when we add stuff together, when we have something like 123 plus 45, we know that this is the 1s column, that this is the 10s column, and that this is the 100s column, right? This is pretty significant. Like, to be able to write a number like this, rather than writing, I don't know what the Roman numeral would be. M? No, C? C-I? Right? The fact that you can have a 0 placeholder was pretty significant, but that's a tangent. All right, so I could write this. Suppose I had a digit like this that was like A, B, C, right? This would be A times 10 squared, right? That's what 100 is, plus B times 10 to the 1, plus C times 10 to the 0. Anything to the power of 0 is 1. Right, so this is why this is called a base 10 number. So what restrictions do I have on these individual digits? What can I put in these boxes? Yeah, so here can go from 0 to 9, here can go from 0 to 9, here can go from 0 to 9. Now, so generally if we have a digit, a base 10 digit that looks like this, leading digit, following digit, third digit, up to the, let's say, kth digit, right? If this is a base 10 number, it expresses itself like this. So it's D, shoot, it would have been much better if I wrote this the other way. So let me exchange the indices here. Let's make this D naught, and then dk, k minus 1, k minus 2. Okay? So we have dk to 10 to the power of k, and then dk minus 1 to 10 to the power of k minus 1, all the way down to d naught 10 to the power of 0. Right? So when we write a number like 43,728, we're just so used to it that we don't think about doing this exchange. Now, the reason that this is base 10 is because these are all base 10s. But there's nothing prohibiting us from changing the base. Right? So if I wanted to write something like this, but exchange the base, I could do so. Right? I could say I have a leading bit, then the following bit, and the following bit after that, all the way down to B naught. And I can say if this is base 2, I should expand it like this. bk 2 to the power of k. Plus bk minus 1. I wonder if you know you're in a lecture hall, right? Like, so all the sound gets projected to me. Right? So if you have a question, I'd happily answer it. Right? And this goes all the way down to this. Right? All I've done was exchange the 2's for 10's. So what can these numbers be now? Right? These numbers bi. What are they permitted to be? Here, I said that di could be anything from 0 to 9. Right? What could it be here? Yeah. 0 and 1. Okay? So if I give you a number like this, 1, 1, 0 in base 2, right? So the reason people get so confused is because they read this as 110. You're reading this as 110 because you've never worked with other numbers, right? But really, when we're working with bases, we should specify just so we don't get confused. So I'm saying, here's 1, 1, 0, but interpret this as a number that's base 2, right? So I have 1 times 2, 0, 1, 2, 2 to the 2, plus 1 times 2 to the 1, plus 0 times 2 to the 0, which is what? 4, 6. So this is 6 base 10 system, right? This is not very difficult. Should we do one more example? Because now what I want to do is write a program that, given this as a string, right, converts to the base 10 number system. Right? And that shouldn't be overly difficult, right? So is this enough explanation to sort of do this conversion? And all you have to remember is that when we're writing numbers, right, that their placement in the number sort of gives you what, if it's a 10 or 100, or in this case, what power of 2. Okay, so let's write a function that can convert from binary into decimal strings, right, using only the material we have so far. Okay, so how can we do this? Okay, so I wanted to find something, what did I call it? From binary. So we have from binary, and I want to take some bits, right? So bits are the digits, right? So a base 10 number is comprised of the digits 0 through 9. A binary number is comprised of the bits 0 through 1. And what do we want to return? We want to return an integer, right? So it converts the bit string into a base 10 number. Right, so we want to take something like from binary, maybe 101. What should that return? See if you learned anything. It's also my favorite number. What about this one? From binary 11001. This is 1, 2, 4, 8, 16. Uh, 16, 20. Okay, so this is 1, 2, 4, 8, 6. Yeah, 24 and 1 is 25. Perfect. Okay, so I'm going to. So how can we do this now? What do we have? Right, I can crawl through the bits. Right, that bits. I can look at each individual bit, and then I want to sort of start with an answer, which is already kind of wrong, right? I shouldn't set answer to 0. Like, I don't know. Let's just assume bits is non-empty. Okay. So I'm going to set answer to 0. So how can I start accumulating, right? We don't have range. No. Otherwise, that would be the answer. Yeah. Okay, so I want to do two things here. I want to have a count. Right? I want to know what position I'm at. And I want to actually start counting backwards. Right? Because I'm going to crawl through this string like this. Right? So I'm going to say, okay, I'm going to look at the first thing. And the first thing needs to be multiplied by 2 to the power of the length of this, right? So I'm going to say, I'm going to start count at the length of bits, right? And then I'm going to accumulate an answer. I'm going to say answer is equal to, I'm going to cast b to an integer, right? Because it's either going to be a 0 or a 1. Let's just confirm that that works. Int 0, int 1, perfect. And I'm going to multiply by 2 to the power of count. And then what should I do with count? Right? As I move down the list. Yeah. Yeah, I should minus equal 1. Right? So the first bit is at the kth position. The next one is at the k minus 1th position. The next one is at the k minus 2th position. So this should now work. Let's give this a yes. For b bits, for b in bits. Okay, let's give it a try. Python Wednesday. We have from binary 101. I screwed up. 1 1 seem to always be returning 2. So why is that the case? What mistake have I made? Yeah. I need to accumulate. Thank you. Right. All right, let's try again. Okay, so now we have from binary. Let's try 101. That's also wrong. Thank you. Right, because we're indexing from 0. Yeah, because I'm indexing from 0. Good catch. Sure, I could also do this. Totally equivalent, yeah. Again, there's multiple ways to skin a cat, though I've never done it. Okay, let's try again. Okay. Good. Roger. Let's check the one that we did. Perfect. Okay. So I'm just going to print here what we're doing. We're accumulating int b times 2 to the power of count. Okay. Right, so this is exactly what our code's doing. It's looking at this. It's saying that we need to accumulate 1 times 16, then 1 times 8, then 0 times 4, then 0 times 2, then 1 times 1. Right, so this is a cute program which converts binary strings into base 10 numbers. Before we continue, is there any way that we could break this? Right. So I guess if we put something that's not supposed to be there or empty. But I'm talking more, oh, right, I'm not supposed to accept that. Yeah, that violates our assumption. But that would have been an interesting edge case. Like, I want you to start getting in the mode of saying, basically of saying, is my code wrong? Like, in what ways could my code be wrong? Right, check your work. Because you won't be able to run your stuff through a compiler on your exams. Oh, so I want you to start practicing coding on paper. Right? Code on paper and then type it into the computer. Because I don't want you guys to be shocked when you get to your written midterm and exams. Right? This is a totally different mode of programming onto paper than when you're doing it into a compiler. Right? So practice with pen and paper. Right? And furthermore, that's how like Google and Facebook and Twitter are going to test you when you go get your job interviews there. Right? They're going to say, here's a question, go to the board and write your solution. You don't get a computer. Okay. Write a function with the following signature. Contains digits. Returns true and sees has a digit. This one's super easy, right? Contains digits. Remember we were doing this the other day. Can anyone express this as a mathematical statement? Right, we basically want to check that checks there exists C in C such that C is a digit. Right? That's how I could express it mathematically. We want to do something like contains digits, go 1, 2, 3 is true, and contains digits, this is false. Okay, so how can we do this? Should be very simple, right? Yep. Okay, so, but we could just have applied isDigit to like the whole input string, right? Oh, right, because it's mixed. Okay, you're right. Okay, so if c.isDigit, then I want to return true. Else I want to return false. Yeah? Or this may be isDigits. Yeah, this seems right. What? Okay, so let's try running it. I'm just not sure if what the is it isDigit? Okay. Okay. isDigit. Okay. So at the back of your exam, you're actually given a list of all the built-in commands that you can use. So don't stress out about like not knowing the difference between isDigit and isDigits, because I don't even know the difference, right? Contains digits 1, 2, 3. Perfect. Perfect. Great. Okay, how's another way we could have done this without the built-in? Suppose you forgot about the built-in. Yeah, you. So I can put that all into the same statement. Something like this, right? That should still work. Or not. Right. So I need to do this. Great. I don't know, I almost kind of prefer this, because it's very explicit. Bruh. Complete the following. Final 2016 question 3. Define valid valid password, which accepts a password and returns true or false depending if that password is valid or not. So a valid password must have exactly 8 characters, it contain at least one uppercase letter, contain at least one lowercase letter, a digit, and one of those special case symbols. So how can we do this? This one doesn't require a loop. This one just requires some if statement. Okay. Def checks password. Check password. It's going to accept a password, which is a string, and return a bool. I know that's a really long doc string. Okay. Returns true if and only if pdub password is a valid password. And it can say something like C slide 6, right? Let's put in the docstring examples, though. Oh, there is none. Okay, let's invent one. Exactly 8 characters, at least one uppercase letter, lowercase letter, digit, and that. Okay, so check password of 1, 2, 3, 4, 5, 6, 7, 8. That's the right length. It needs to include one lowercase letter, one uppercase letter, and a special character, and a digit. Great. So that should return true, and check password of password is false. Okay, so what do we have to check here? And how can we check it? Yeah. Okay, let's check the length first. If the length of PW is not equal to 8, return false. Right, so I'm going to cheat here, right? Instead of like nesting a bunch of if statements, right? So there are 2 ways of doing this. We can check that the string is valid, right? And bury if statements. Or we can check if the string is invalid. And then assume that if it's not invalid, then it's valid. So I'm going to do the second one because that ends up being simpler, right? I'm just going to check that each condition doesn't fail. And if none of the conditions fail, then I'm going to return true. Right, so if the length of the password is not equal to 8, return false. So what else do we need? We need one uppercase character, okay? How can we check for uppercase characters? Using only what we have. Okay, so I guess I just have to do this. The uppercase characters. Yeah, what's up? Right. Okay, yeah, you're right. There is a better way of doing this. For P, so for a character in the password, I need to check if C is in between A and well, we need to check C. Yeah, here, right? Or something like this. But this is checking if the condition is right. But I want to check the violation of that. Right? I don't want to check. Yeah. Yeah, that's the other option. Yeah, like again, there's multiple ways of doing this. I just thought this was going to work out. So we need to look through. Okay, so I'm going to use your idea. I'm going to. How many conditions do we have? 5. So condition 1, condition 2, condition 3, condition 4, condition 5. Right? No, that's dirty programming. We can do this smart. How can I do this smart? You can
set a checker to false, and then for each condition that it passes, set it to true.
Yeah, I can set a switch. That's what I'm trying to avoid. Okay, I'm gonna do it the way that I was starting to do it. I was gonna say this: uppercase characters are A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W. Did I miss anything? A no, Z's not a real letter, guys. Okay, so if okay, I'm just going to do it the dirty way. Condition 1, condition 2, condition 3, condition 4, condition 5. Right? They're all equal to false. 1, 2, 3, 4, 5. And then I'm going to return C1 and C2 and C3 and C4 and C5. Right? This is going to work. Right? I'm going to check each of the individual conditions and toggle them. Right? So if the length of the password is 8, right, then why does that keep happening? Then I can say condition 1 is true, right? Okay, so if I'm going to now go through the password, look at every character. If C is in between A, uppercase, and Z, uppercase, then what do I want to do? I want to set C2 to true, right? Yeah. Oh, sure, we can combine them. Okay, so I'll use the same loop and say if A is less than or equal to C is less than or equal to A, then the third condition is true. Z. What's the next condition? A digit, okay? If C is in between 1 and 9, oh, sorry, 0 and 9, then the fourth condition is true. And then finally, what were our special characters? Bash. Okay, so we need this, 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 and asterisk. So I need if this is in the password, or this is in the password, or this is in the password, or this is in, yeah, the password. The fifth one is true. Yep.
Could you just declare string literal with all those string and return C5 equals true?
Oh, sure, we could do it that way too. So I can say, sure, I can reuse this whole thing, and I can say if C is in brat ba ba, then C5 is true. Okay, yeah, I think that was better.
And do you need to escape the percent sign, or can you just leave it like that?
I think you can leave it like that, yeah.
If you set all the conditions to true, then a try check would be false. Would there be a chance that the loop would run and make it work faster?
Well, this loop is going to... Yeah, it could work a little bit, but we're talking about something which is going to be max 8 characters, right? So talking about efficiency concerns about something that tiny is, yeah, kind of a joke. It's 8 characters, right? So, okay, this should work. Let's give this a try. Again, like there is an infinite number of ways to rewrite the same program. Okay, so let's check password. This, I guess. Should be true. Come on, true. Yeah, come on, false. Hooray. 1, 2, 3, 4, 5, 6, 7, 8. False, great. Okay, continuing. How far did we get? Geez, not very. Okay, so there are 4 more questions. I'm going to show you all 4 of them, and you tell me which one you want me to do, and then you do the rest of them. So here's a question. The goodness of a string is 0 if a string contains anything besides 0 and 1s. Right? So a string of 0 and 1s has goodness non-zero. Otherwise, C's goodness is given by the numbers of 1s in the string. Right? So if you have 0, 1, 1, the goodness of that is 2 because it contains only 0s and 1s and two 1s. The goodness of ABC is 0 because it contains something else besides a 0 and 1. So that one shouldn't be too hard. This is very similar to the binary conversion one. Zigzag. This is the question 1 from Final 2016. Returns a string comprised of alternating letters from S1 and S2. It assumes that the length of the inputs are equal. So zigzag zig on ABC 1, 2, 3 is A, then 2, then C. Zigzag zig on A, B, C, D is A, then 2, then C, then 4. Right? You're choosing one. You're alternating between the 2 strings. Question. Write a function to check if a string is a palindrome, i.e. a word which is the same as its reverse, like race car or dad. Write a function that takes as input C's and a character, C, and returns the rightmost position of C in C's. If C is not in C's, then return -1, and do not use the built-in find. And finally, complete the body of the following function. This is from the Final 2017 question 4a. Take in a string, and then return 2 strings. One string contains all the vowels in reverse order, and the second string collects all the non-vowels in the natural order. So Catherine wants to go to the zoo, would give you this. These are the vowels in the reverse order, 0, O, O, E, O, O, A, and so on. And then this string is this string with all the vowels removed. Right? Right, so which one do you want me to do? Any preference? No? I pick. Write a function to check if a string is a palindrome. I'll do that one. Okay. Definition is palindrome. And let's not... Okay. Actually, what is the easy way to do this? We can do this basically... You already have the tools to be able to do this in one line. Mm-hmm. Is the word equal to its reverse? Done. That's why I chose it. Okay. So don't overcomplicate things in your exam, right? Like sometimes there just is a super easy answer. Okay, so let's talk about efficiency concerns then, right? This would be a really dumb way of doing this efficiently. Because suppose I gave you a huge string, huge, millions of characters. Then the first thing you're going to do is double the memory, right? By creating another word that's reversed. like you actually want to walk through the string and just check the indexes, right? But I can't show you how to do that until we have range and you know what a list is. But yeah, you want to check that the 0th... Actually, I think we can do this. Can we do this? I don't think so. But any case, let's just check. Let's just check if this works. Is palindrome race car? Yes. Is palindrome car? No. Is palindrome Arizai as I? The longest palindrome is like something about Napoleon, but I forget it. Yeah.
A man, like A-M-A-N, plan, canal, Panama.
No way.
Yeah.
Wow. That's cool. Okay, now what's the one I wanted? Ere was I as I saw Elba. Aha. Able was I ere I saw Elba. So this is about Napoleon. Does anyone know what the island of Elba is? Yeah, that's where he was sent to prison. What's it called when you're sent away? Exiled. There you go. So now we have 2 really wicked long sentences. One more? Or you guys want to go? One more? Let's do the goodness one then. Definition, goodness of a string. Bool checks the goodness of a string. So something like goodness of ABC should be 0. Goodness of 11011 should be 4. I can write this real fast, right? So I'm going to accumulate something. 4C in C's. Why does that keep happening? If C is not equal to 0, well, I can say it like this. If C is not in 1 or 0, if it's not a 0 or a 1, then return 0. Else, I have to accumulate answer by the integer value of C, right? It's going to accumulate a 0 or a 1, and then I want to return the answer. So let's see if this works. Perfect. Great. Great. I think that's technically correct. 0, 1, 1, 1. Okay, great. So I've done a bunch. So how many have I left for you? Do this one. This is a good one, this repeat character one. So I want to give you a string and a number, and I want you to return me a new string which, I don't know, doubles everything. I don't know what this only vowels is. This should be a repeat character. Otherwise, Friday, optional. If you want to head home early to your families, I totally understand. I won't hold it against you. But otherwise, for those of you who do come, I'll be giving you a little lecture on neural networks. So see you Friday.